In the last video, we looked at tool use. There, the model calls predefined functions, functions that we as developers have already described and made available. However, we can go a step further. Instead of only calling functions that exist ahead of time, we can give the model a way to create the function on demand by generating real code and executing it on demand. This capability is called code execution, and it unlocks far more flexibility. Let's take a closer, practical look at how this works. Let's look at a simple example. If we ask an LLM, what's the average of these numbers, 10, 15, and 25, the model might answer correctly, but it might also hallucinate the math. With code execution, there is no guessing. The model can write real Python code, run it in a sandbox, and read the exact result. For example, the model might generate the code we see on the screen and run it to get the correct value. As a result, the model then responds with the precise value and not a guess or approximation. Why is this significant? First, the model is effectively augmenting itself. Even though an LLM is not a calculator, it can generate code, run it, using code execution as a tool, and use the output to provide the right answer. This lets the model accomplish tasks it would otherwise get wrong. Second, notice that we didn't need to predefine a function like calculate average. The function is created on demand by generating real code whenever it is needed. So there are two important capabilities at play. One, the model extends its own abilities through code execution. And two, it does so dynamically without requiring us to prepare every function in advance. This is what makes code execution more flexible and more powerful than conventional tool calls. This essentially enables a unique new capability that can be applied to almost all problems. To make code execution possible, we expose a tool that the model can call whenever it needs to run Python code. This tool is very simple. It takes a string of code as input, executes it, and returns the result as structured output. The important point is that the code itself is generated by the model. We do not predefine every operation. The model writes the code on demand and the executor runs it. So this tool acts like a programmable function. The model can produce new capabilities whenever it needs them. To keep the example easy to understand, we'll use Python's built-in exec function. Exec let us execute a string of Python code and capture the result. There are safer sandbox methods for executing code in production, but we are using this simple version to show the core idea clearly. In our simple example, we use Python's exec function because it makes the core idea very easy to see. The model writes code and we execute it. But running code directly can be unsafe because the code might access files, send network requests, or perform other changes on the system. In real applications, code generated by the model is typically executed in a sandbox, a restricted environment that limits what the code can do. A sandbox can block file system access, block the network, restrict available libraries, limit CPU and memory, stop execution automatically if it runs too long. This way, we get the benefits of code execution without exposing the system to unnecessary risk. Common ways to sandbox code are running Python in a separate process with limited permissions, using a container like Docker with no file system or network access, usually specialized sandbox services that run code in a locked down environment can also be used. So for teaching, exec keeps things simple, but in production systems, sandbox execution is the standard approach. Let's look at the complete workflow for code execution. The user asks a question, what is the average of 10, 15, and 25? The model decides that running code will produce the most accurate answer. It generates Python that calculates the average. We pass that code to our execute code function, which runs it and returns the exact result. The model then reads this output and produces the final formatted answer. So the agentic AI system isn't estimating or guessing. It writes real code, executes it, uses the exact output, and answers confidently. Code execution is a critical building block of scalable agentic systems. It allows models to extend their abilities and solve problems they otherwise couldn't, and act with far greater accuracy.